Yeah, so good day everyone. Trust you good. So we'll be having our session two. That's where we stopped last in our last class. So we'll continue from there today. We share my screen and so please can you see my screen?
You can say it.
You
Yeah, we
said?
can.
Okay. Yeah. So session two probably did not to be sent across very soon. So in our last class we, we go over what Docker is, and some basic concept that we need to know, and also some simple commands and how to build and run simple containers, right? And also how to build our images to Docker up. Yeah. So today, what we're going to be looking into is we're going to see how we can actually build a simple application. So not just ordinary command that we did in our last class, then deploy a simple application and see how we can access it on our machine, and also learn to learn some advanced concepts on Docker commands, right? And also check and look into what multi-stage build is. Yeah, and so just we might actually look into run to cloud here too. Then our last class we'll see how we can deploy to a cloud provider, probably AWS and then above. So I already have a simple application built. Yeah, and so this is the project structure for the application. I'll go over it before I'll go into the real practical. So just go through the notes together. I'll explain. Sorry, before I continue, does anyone have any question regarding what we did in last class? If there is, right before I move on, so you can just ask for clarification so that what we want to do today, there won't be any mix of ideas. And if there is none, you can just move on. No question, right?
I don't think so.
You said?
I don't think so. We can proceed.
Okay. So yeah, so when you're structuring our Docker file, so the structure is very much like it's very important for us to make a Docker file be simpler, easy to maintain, and also follow some best practice. And for other developers looking into your code to be able to understand whatever you have, for them to be able to understand it. Yeah, so these are the important of us having a structured code. Yeah. So in order to manage our dependencies, so the dependencies are the packages that we use in our code. Right? In this case, we'll be using Python as language that we use to build the application. Right? So the dependencies that we used in the Python code is what will be added to the requirement.txt. That's a file. So this file is just a file listing of Python packages that your app needs. You understand all the packages that the app needs to run on your local host, like this when you are testing, when you install the packages that oh, I need this, you install it, then you make sure of it. So the same thing when you wanted to build a Docker file, a Docker image, you definitely need to build all these dependencies together. So for us to be able to install this thing inside the container, to have inside our image, to be able to run it inside the container, then we need a simple something like requirement.txt that will have all the necessary dependencies, right? So for the application, that Flask application, simple one that I built, so these are the things that we need. So go to the practical application, you see it there. Yeah. So if you're now creating requirement.txt, you can do it in two ways. So it's either you manually just write it one by one that oh, these are the dependencies that you need and the packages that's needed by the application to run successfully, or you can use Python pip freeze. Yeah, this command. So you use pip freeze and then you direct it to requirement.txt, whether the TST is created or not. So it's going to create it and then it will automatically input all the dependencies inside it. But The thing about this pip freeze is that it will actually include everything installed, like everything that you have installed, like the what's it called, the packages that you have installed. So it will just include, it just move everything to the requirement of test. It doesn't care whether you use it in that particular application or not. So it's recommended to just input it manually, like yourself. Just look at what you need and then input it manually yourself. So one of the best practices for requirement.txt is the text file. Yeah, is to always use pin versions like this.
Can you please enlarge your screen?
Let me see. Coming. Yeah, I think it's better now, right?
Yes.
Okay, yeah. So, so the best practice is to use pin versions. So pin versions is that you have one particular version that you need, that you wanted to point to. Like for example, as you see this one, this numpy now is using 1.26.2. You understand? So that's a pin version. So if you didn't include any part version, like just leave like just put numpy. The thing is, it's going to fetch the latest numpy for you. And it's very possible that your application doesn't have the necessary requirement to actually run the that latest number. You understand? And if in case you actually use that latest packages to run your application, for example, now currently, in future, like in future times, it's very possible that to be outdated, like some part of the codes might not work together with the latest update. You understand? So one of the things that this thing will do is that for forever it's going to be fetching that particular application unless that particular version rather, unless the version is no more available again. That's when you're going to have some issue that okay, you have to probably upgrade or something like that. Yeah. So yeah, for reproducibility, and also make sure that you include the packages you actually import, like all the packages that you import in your application. Make sure that you have them inside the txt, and also try to keep it minimal. That is, all the required, just make sure that it's only the required dependencies that's inside that requirement of tst. You understand? And also just all the complex dependencies, you can just comment them out. Like all the complex one I don't really need. Yeah, just leave it out, because all these things actually contribute to the size of your image. So everything you are input you are putting there, it will add to the size of the image after you build it. So now the application, you still go through it very well, like you still go through it. But this is the file, the Python, the Docker file. Is this using Python 3.9, the Slim, right? Then we have this and then this is the requirement of txt. You set the working directory here, then move the requirement of txt to the current. The moment this thing got we send working directory, that means everything is going to run inside this slash app. That means we are in that directory now. So I'm moving copy the txt, like requirement of txt to the current part. Then you run Python, install local directory, then all the file, like you install the file. That is this file that we are installing. That's why we put R here for it to know that okay, this is a file. So it will install everything that's inside that requirement of txt. It will install everything inside the file. If probably you only have like 2 to 3 this thing that or one at times, you can just ignore the requirement of txt, except you think it might be suggested to update in future. You understand? You can just install that one particular application here, like one particular dependency here. Yeah, then you copy the application code itself, remove it, then you expose the port that you need, then command that needs the application to run. I think I've okay, we still get to explain something here very soon. Yeah, once we got there. So the real explanation, I think I've already did that. So the Python 3.9 Slim image, it's smaller than full Python image. So it's smaller and then it's okay for our requirements. So it doesn't have any unnecessary packages, then smaller in size. Just imagine 150 MB compared to almost a gig. Yeah. So and that will definitely have effect on our application, like on our image that we're going to build. So I've said earlier too. So the moment you create the directory here, the all the subsequent command that's going to be run will be run inside this directory, inside the path. Then it copies only the requirement for us. Then you separate them from code, like all the dependencies because of Docker caching. So I think I explained a little bit about this thing last in our last class too. So let me just try to explain this. When you are writing your Docker file, the best thing to take in mind is that don't copy your application code before this, or you use the same command for them. You know that, for example, now, I'm coming now. For example, if we use copy, copy this into this, or like this, yeah, or like this, just copy everything inside the directory here and move it into the app directory. That is everything, all the code, all everything that we have in this directory, this structured file that we have, and everything here. It's going to move everything into the image that I wanted to build, like it will move them and then to now run. That means for every time there is a changes in our code, probably you just made an update, it's going to copy all the codes. And you know, copying code will definitely take time more than this normal, um it will take time compared to requirement.txt one. Secondly, is copying code is subjected to changes frequently than dependencies are, because all the you might be using the same dependencies and the same package, everything, and you just be updating your code. Probably you are creating some part of the code, you are just increasing the interface, trying to make it perfect without changing, without needing to import or download any new package. You understand? So that's why you have to install, like you have to copy this requirement first. When you copy these requirements, then you install the required dependencies. You understand? So Docker already have it cached. The meaning of caching is that it will actually make them available so far there is no changes to it. Whenever you wanted to run it, it will just like it already have the data. So instead of it to be rerunning it, it won't even rerun. You just use the previous one that it has run and it will use it, and then so that the time will be minimal. The time for building will be very minimal. So then you now install this. The moment you install the packages, then this thing, like no catch that means don't save any pip catch to reduce image size. Yeah, because pip too normally have its own cache too, so you don't have to save that one. You don't need it. Yeah, so it will, because that one too will also contribute more to our Docker image. So you don't need that. Then you now copy the code. The code that we are now copying now, you know, it's very possible that we change our code often. So if you change the code often, that means whenever we wanted to rebuild our image, everything from the start till here will just run like within milliseconds. Everything will run. And so this just keep to this step. And then we started building the application. Like you start to rebuild this particular step. Uh, then now export the port. Then just use this document only as actually it doesn't actually open the port here, as I've said in the last class too. So it's just like documentation. This export like expose. Is when you wanted to run the code, I specify which kind of port you want to use. You understand? So it doesn't really have effect. Just for you to know that, oh, the application, probably the application itself is only on this particular port. Uh-huh. So, and this command, this last one is the command that the contain that normally start the application. You understand? So that's the command that start the application. So that Docker layer in caching, the layer caching. Yeah, let me explain this. So how do you copy requirements separately before copying this? As I've explained, I've already explained that one very well. So it's a very bad practice for us to just copy everything at once, like using this command. Is bad practice. Copy this and then now install. No, doesn't really work that because every time you make any changes to your code, my only no this one is because you only have a file. You soon got the show I showed you the code. So it's only you have a file. That's why this one might be like still to some extent be a little bit simpler. Right? So it will install all the packages every time because it has noticed that there is a change in that particular layer. So definitely it's going to rerun everything in that particular layer. So it will be reinstalling the packages every time. It's going to make our distance slow. It will be it definitely lead to waste of resources also because the data that you're using. So this to the waste of resources and waste of space also. Yeah. So good practice is for us to just follow that part, copy your requirements first, install the necessary part and the necessary requirement, then copy the code because Docker works basically on catching, right? So and it only rebuilds when the requirement of test changes. That is, this particular change, what's it called, layer will only repeat if anything changes. So if we run the application, like if you build the whole Docker image now, and it takes you like let's say 3 minutes, and you run the same thing, like that same Docker file without changing anything, it might take you 2 seconds or 3 seconds. Like if you run the same thing immediately without changing anything, because it doesn't rebuild any layer. So it's just use cache for everything. And it's just even if you change another name, like probably your image name before is ABC, and you just change it to ABD. That ABD will just take probably 3 seconds for everything to be run, and then you just even it might be less because it's using cache. There is no change anywhere, so you just use cache for everything. It's only when Docker notices okay there is changes in this particular part that's when it's going to it's going to just run that particular layer. And if it changes anything, everything, it's going to run everything too. That's why you need to be cautious on how you actually copy your dependencies, the way you install them. Yeah. Then the ports also, the ports now you wanted to know the ports that were opening. That is the one I've said. For example, the 5,000 ports that were opening before. So but they are just like dot to the application exactly that we used to access the application on the on our web browser, right? So Flags run like the Flags package and the Flags Python, the Python, or then say Flags, you have Flags as dependencies as a to be like as one of the things that we use to build a Python application, right? You can use the Django also, but for this one we're using Flags. So it was run in default port 5,000 by default. So then inside the container, you can just make the ports to listen outside, like inside the container, you can be listening on 5,000 and outside the container, you can map it to our computer 5,000, we can take it to another port. But the application itself that's running, because that application now that has 5,000 on our application without using, on our computer, for example, um, without using Docker, it will be 5,000 to run if you run it normally. So now if you now run it on Docker, that 5,000 will still be running inside Docker, but you can map it to a different port on your normal laptop, like on your normal computer. You can just change the ports. That one is very possible too. So, and if you want it to be running on the same 5,000 too, you can just map everything together. You can just tell, okay, ports 5,000 and 5,000. So it's going to be mapping. So for example now, this is port mapping. If you wanted to map the port, the moment you run the application, just specify this flag port, like flag P, that means the port. Then Docker, okay, this is the port. This first one is the one on your own computer host itself, and this one is the port that's running inside the container. Then you specify the image that you wanted to run. You understand? Yeah. So then, if you go to your host browser and you input this thing here, you'll be able to access the application that's running on 5,000 on your container, right? So, for example, now this is how it actually works. Normally, the browser localhost, you try to access it from 8 to 8, then Docker maps this 8080 to 5,000, right? Then Flask application that's running is actually running in on port 5,000. Yeah. So the one you now use 0.0.0.0 in Flask, because majorly when you are building an application, this is how you actually put it. So in the application of bits, why do you use this 0.0.0.0 means that the IP that we use actually means listen on all network interfaces. It's listen on everything. Then it makes Flask accessible, like our Flask application, that's what we're referring to as Flask. It makes it accessible from outside the container. So it can be able to map to other port and be easily accessible directly via another port. If you had used separate IP, it won't be listen to every port. So you have to specify it every time you wanted to run it. So without this, flags only listen on localhost inside container, you can't access it. Yes. So without specifying this one, it's only be losing on the local host inside container. That means it's only the container that this thing will be running inside. It will be running totally on private network that is, because it's not open outside. It didn't give it chance to open. So if you use this 127.0.1 or 1 or local host, because this is ideally the IP behind the local host too. So it's running on inside the container alone. But if you use this 0.0.0.0, it will be accessible from outside, and it's not only in Docker. It's actually applicable to everything. So probably if you are deploying your this thing on cloud, you use this particular port. That means you want your machine or anything to be listening on every, like to be listening to everything outside the local host itself. So now let's talk about environment variables, because in building your image, like your application you want to run it, there are times that you need environment variables. So what are environment variables? They are the variables that you can pass to container without changing the code, right? So majorly if you wanted to, you can use it for configuration, debug, you can use it to debug ports, database URL, feature flags. These are things that are actually subjected to changes, right? So using environment variables in Docker, these are used for example now. Just specify that okay, env flask, that's this env stands for environment, as you've seen here. Then Docker flask is a variable name and the key production. Then another environment variable port by 5,000. That means if you have this thing inside your Docker file, when you are running, so when you are running this Docker file, when you're running the container file, you can change this variable to another thing. Like okay, you want it to be development, whereas everything will be inside the code already. So the code will understand that oh, when you're running your deployment, there are some particular things. Okay, you use this environment. You don't use production grade stuff for development. Okay, you are developing now, and you have this on port 5,000. That means the host is using 5,000 too, and the container is also running on 5,000. So in Python code, you specify it here that oh, if you are debugging, you are on development, so you can debug. For example, if you specify that oh, your Flask environment is in production, that means the debug mode won't be on. You don't turn off the debug mode to set it to false. And you can also say that so app run host, this host that's opening to listen to any ports, right? Any link. And the port goes to the port that was given. Yeah, this. And then debug, you want the debug to be true or false. So it depends on whether you set it on to production or um, development. So to automatically update that. So Docker ignore, that's where we've treated this to in the last class that okay, exactly like git ignore. So it tells Docker one not to copy to the image and stuff like that. Even the Docker file itself, you have to copy it because you are not building any image inside the container, inside the image itself. So you don't have to copy it, just need to use it to run your this thing outside. Because it's going to make us like it to reduce the image size, build it file, and then to copy it won't copy unnecessary files. So now before we actually go to the practical itself, we have practical itself. Yeah, we maybe I should just go directly to the practical part of the thing so that yeah, I'm coming. Let's talk about this so that we go to practical side of the thing. So the command that we use at the end of our code majorly of most times and entry point, because you do have entry point too. Let's see what the like what's the difference between them, what's the similarities. So both specify what commands run when container starts, but they work differently. So this entry point also can actually use it to tell Docker that okay, what does this thing, what does container runs, and also the command also. We've been using command, that's CMD in our previous this thing, everything we've been using. So for command, it's actually easy to override and provides default command. This is the example, just Python and app.py, but you can override it by just running that. Okay, we have Python version, like you change the Python version instead of this, because you are to tell this thing that okay, use this Python, then you run another command entirely. That means it's only this thing, and if you run it, you only check for the Python version that this thing is actually built with. You understand? Because you're passing another argument to the to Python itself. But for entry point, it cannot be easily overridden. You cannot just override it like that. And container always run this command. Container always run it. And argument pass to container are added to entry point. Yes. So if you pass any argument to container, they will be added to the entry point. Example now, see, just put Python entry point then command. You know that entry point means this entry point now. This is the point that this is like the starting point too. You already have with Python. So that's for you to now come back and then change it to another thing, it won't be very easy. But when okay, let's just follow this normally. Then the command, the argument is now under this command now, right? So they will be added to this and run both together. When you now run Docker run this, it will just run the command directly because it will understand that oh, you are using this to run this argument. To take this in as an argument and to run this. Then if you run this with version, it will run Python version. It will override this command, but this one it won't override it. You understand? So you don't have to make what's it called Python again here. You have to make Python code because they already run this entry point. It cannot override it. Yeah. So I went to use it. Simply is just for like general purpose application. Then once you override, if you want to override it, probably you're testing the application frequently and you want to be able to override some parts, and just use that one. And probably just normal typical web applications. Right. Then for when to use an entry point, you use it when to the utility container to wanted to fix behavior, then creating CLI tools. So using something that's more serious compared to CMD, right? Then multi-state build. When I talk about multi-state build, that means for us to be able to build, create smaller, more secure images by using simple from statements. That means the from statement, you normally use it as once, and it's not usually be at the beginning, right? But in this case, we're going to be using it like twice in application. So, for example, problem now is to build tools, build your final image. Yes. Then solution is to build one stage, copy only once what's needed to another. You just build with one, and that thing that you need, you just copy it to another build. And then that's why we have multi-stage build. You understand it now. First is stage one, you build the stage build itself. Just copy wherever your this thing is, your builder is. That is the node like the let me say the runtime that your application is built on. You copy it and then you just put it as okay. You import it. For example, it's like you're importing it as something. You've code with probably JavaScript before. You understand what I'm saying here. You just tell him that oh, from Python as builder and everything that has to do with installation of packages and stuff like that. You do it here. Then you already have the necessary dependencies and everything built. Now you now move to the second stage. That's runtime stage. I want to run it. You now set this thing again. Like you copy this that oh from Python, use this the runtime that you need again working directory, and then you now copy everything here that's installed packages from builder. This builder that was built before, everything that was installed there. You just input, like you import it from this part to the part that's been needed, right? Then we are inside the app directory now. This app directory, then we are copying it to this particular app directory here. Then the file, your Python code or any code, now copy the code itself too, right? Then you can now have your script, your parts, environment parts, that is the local. That's where everything that's been built from this builder is. Then your expose your application. This thing will be it's because the application is actually very simple. That's why you might not see the usefulness for now. But if you are building a very robust application, you will definitely need something like this. So benefit is going to make our image smaller. If our image doesn't include pip, so everything that has to do with P, all the build tools, it will have it inside it. Yeah, because we only build, and after we build, we just copy that build stuff that's built. Then we copy that one and just make use of that build inside our code. Not that we are copying everything that we used to build it inside the code again. Because everything we've been doing, all what we used to build is actually together with our file, with our code. So it's actually less to transfer and store and more secure. Fewer packages cause to because exactly cause to fewer vulnerabilities because all the packages too they do have different kind of vulnerability in them. So the more you can actually make it few is definitely the more you're going to have few vulnerability in your code. So that's type of that. So all this we're going to go through it. Let's move fast so that we can just go to the application itself. Then yeah. So introduction to cloud platforms, right? So we'll see. Maybe I was just let me go to let me run I'm coming. Let me share my code screen. You can now see my editor, my code editor. Hello, can you see my code editor?
Yes, we can see.
Okay,
But
then, then
try to enlarge this more.
yeah, I've did that. So yeah, this code I just use what's it called? I just use um the cursor here to just build this simple application. It more of like a machine learning app, but a very simple one. So to just train a very small machine learning model on classic IDH dataset and it just run once the computer Python process starts. Yeah. So let's see the Docker file. That's what we are really concerned about. The Docker file and the Docker ignore. So in this, the last push that I was showing here is because there is one particular this thing installed extension. So it's telling me that the particular what's it called runtime that I'm using. So that's the last time it's been updated on their end, right? So we said the working directory, they'll copy the file for normal catching that we treated earlier. Then this one will install the dependencies and copy the application code. Can just copy everything. Though you can just normal copy, you can only copy this directly like on the app.py. Using this dot means you are copying everything. That means aside the file that have our code alone, you are copying everything in that directory too. That's what it means. So exposing the ports, and if you don't forget, you said this port is just like a documentation, just to tell the probably the future developer or something that okay, this is the port that the application is running on the container. Knows that it's going to open the port on your host automatically, and then the command, Python command, this is the Python command that's going to run in our application, right? So now, what we're now going to do now is that we're going to build the application. So we build the application with the coming, then we build with test. Okay, let me show you this thing too before we move on. The Docker file, Docker ignore. Okay, I know Docker ignore. So in this Docker ignore now, we can put a Docker file itself inside. You can put Docker file inside. Do you have anything that has to do with the .env? Okay, let's just these are some suggestions that okay, if you have any env file that is all our secrets, everything, you can just put it here. You don't want it inside the Docker image. Then what the Docker image file itself, like the Docker ignore file itself, Docker ignore. You don't want that one too. But the readme, you don't need the readme file. You don't need that too. Yeah, the Python. Now we are using Python, so everything that has to do with all these things now, don't need them. Even our Git, there is this um .git, that's the GitHub folder, like how the editing that we're doing for our version control system. There is this, but majority of all these file folder they actually start with dots. Majority they won't, like majority of them won't display. That's why you cannot see them, but they are in this part. Then that my Python, like this one too, you can just add it there because it's inside that folder also. But let's add it there. My catch, yeah. So everything here. All these things that's been suggested, you can just add everything to, because everything that you add there now is not going to, even the file itself, no matter how much, because we already added the file here too. So it won't contribute anything to the image, like it won't add to the size of the image. Because we already have everything here. Then inside the requirement.txt, we cannot add this requirement.txt inside because we need it. Because we need to copy this requirement.txt to our runtime when you are building the Docker. So as for us to be able to build all the required dependencies with the application. You understand? But for Docker, we only just need this Docker command to run now on our host. Not that we're still going to be need it inside. You understand? Yeah. So basically, these are the three dependencies that's being used to build the application. Flask. These are the three. That's the versions that's being used. We said you use pin version whenever you're building stuff like that. You use pin version. Yeah. So let's not forget. So now, if we're going to build our application now, we just okay. Let's start now. Then we build Docker build Flask application build. Then we tag the name. That is for to tag to tell Docker that, oh, the name that I wanted to build. Oh, I'm coming. Let me run the application first. Oh, I should just don't let me run it then. I wanted to run it first so that I can see what it display on. But we build it and we'll see it. Let's not doubt it. Build. You can give it simple Flask app. Simple Flask app. Then we now tell Docker that, oh, the current directory. That dot means it will, like the Docker file. It's inside this current directory. If you have another file, like you don't have Docker with that name, probably you have the Docker file with dot yeah, dev or stage or anything. You tell Docker here that you specify the file, you use flag F, then you specify the file I want to use that's not with this exact Docker file name. You understand? Yeah. So now let's build our image. What was that? Oh, built. I used built instead of built. Like this. Yeah. So I start to build the application. So you can see this thing. Let's wait for this to build. So it's installing our what's it called? All dependencies now. We have an issue. So we have an issue with the pip that we are using. Okay. Does that mean you have to run it inside the code? Okay, let me see. If you have to run it inside the code itself. If you notice, this thing failed in um this particular layer. You see that everything here is just 0.0 seconds. You understand? And here, if you check here, you see cast. That means it doesn't really run it at all. Just use the cast because there is no changes made to that particular layer. You understand? Because this thing failed, so everything that has been that has run before is going to rerun everything because it has not cast this particular layer. That's why it's building everything. Let's see. This is taking too long. What's going on? Still downloading it too, but while we wait for it to build, let's try and run the application and see the interface. Yeah, let's take it out. Yeah, so this is the application. Like this, the interface. It's running on this port. If you change this to 000, definitely you can actually work because that's the port I will open also. I mean, like this. 0.0.0.0. Yeah, so it's still going to work. So this is basically what it just do. Though this thing is not really accurate, but just know that this is the interface that I expected to see when when we actually build our this thing also. The moment we finish building the Docker image, we run it. We try to map it to another port to see if everything is going to work as expected. Let's see the okay, still running. Yeah, while we wait for this, I don't know if anyone has any question, please you can use this moment to ask. So I'll just try and give justice to that before we move on. This take it too long. Oh. No question, right?
Hello, sir. Good day. Good morning, sir. Good afternoon, sir.
Yeah, good afternoon. Hold on.
This, because since like we are working on a Docker. Just thinking that- I don't know. This platform is it a bit more flexible than AWS?
Which platform?
This the Docker.
You mean the Docker Hub?
Yeah.
Mm, depends on your needs actually, but basically, to some extent, it's still very much like, except you want your everything. You probably want to be running all your application on AWS. Yes, no problem. But because for Docker Hub now, they will still give you some free service that you can use. Like you can store your image free so far it's on public. You only have access to one private storage. If you are using normal free what's it called account, except you want to upgrade probably to enterprise, a lot of kind of support that they still provide that AWS doesn't provide. The AWS have their own part too because you can actually run your application on AWS using some serverless this thing, container run like ECS, Fargate, you understand? So it depends on your needs actually. That's when you can determine which one is the best for you. For someone that was just wanted to learn and understand how this thing works so very well, you can just stick to using Docker Hub. For example, also you can just use one or two projects to practice on AWS or any other cloud providers, or for your own personal projects, you can just stick to that Docker Hub because it won't charge you and it's definitely work the same way also.
Okay. Okay. I think, okay. what I tried to is like, is it like it's an open source free tool, or it's like we need to do subscription on it?
Oh, it's actually free, but it has paid version also.
Okay, that paid version. Okay, okay, okay. Thank you.
Yes, yes, there is paid version. Okay, I'm calling you. Maybe you have to upgrade your Python. I'm coming. Let me see what's going on with that freeze. Let me check the version. Can you see now? I use that pip freeze version. You see that it just put everything and the ones that I don't need, all the dependencies that I have installed. And actually, I just wanted to check the version. Okay, Flash 2.3 to get that one right. NumPy. Yes, it's 2.13. Wow. Why is that issue? Then skit is 1.152 also. Yeah, yeah, yeah. That should be it, but I don't know why you're getting this. I'm coming. Let me. Why is this thing doing like? Yeah, let's try and use the cursor to fix this. Hope that I'll be able to know what's going on. Yeah. Mm-hmm. That means you have to. Actually, I saw it too. You have to update this. Yeah. Okay. Just do that, yeah. No problem. That means you just have to update that particular Python version that we're using. So that version that you're using for Python cannot work with the latest pip, like the pip upgrade. Yeah, I saw it that it suggested we use either 10 or 11 version though. Oh, yeah. So while we wait for this thing to finish build also, let's just try and brief cloud computing. Yeah, so cloud computing, as we all know, like as we all know, is one of the trend in tech before AI, before AI is leading now. So though cloud is actually is taking the place also. So majority of companies that used to be running on their like they used to be running their servers, buying their servers and deploy application, majority of them are now moving to cloud. Yeah. So the cloud computing, the cloud there is something that used to confuse probably new that wanted to cut into cloud computing. The word computing is still somehow very related to computer, right? So but for the cloud, it's just basically like running your running a computer, accessing another computer from your particular computer, like from your own laptop now. Now imagine using that laptop to access another laptop and then running it. You understand? Though those laptops that you're accessing are not in form of normal laptop, they are in servers and they can do some kind of thing that you wanted to use them for. And so benefits is to be able to access your code like your application from anywhere that is being deployed to, like if you deploy it to cloud, that means it's on the internet. If you make it public too, so going to be accessed by anywhere, then it's scalable, so it handles more user easily. If you if you are the type, for example, now you know we are in December, so there are some kind of different. A lot of people definitely wanted to like, oh, let's have okay, we are in break, we have this break, let's just try and go out and enjoy. For example, some restaurant now this December they get the orders that they got increased. You understand? That means for them to be able to meet up with customers' demand, they need to scale up. Probably they will have to hire people. Probably if they are closing by 4, if they used to close by 4, they might wanted to increase their closing time to probably 6 to be able to meet the customers' needs, right? Because they know that by this time, the majority of people that are busy working throughout the year, they wanted to have a break that would want to enjoy themselves. So the restaurant or any refreshment center, they also wanted to scale up so that we meet the demand of their customer. And that same thing that's happening in the restaurants or similar stuff, it's same thing that's happening in cloud too. So for cloud now, if you deploy your application on clouds or any your application, right, might be any of the cloud providers. So there might be some doing free giveaways. If they're the type that probably an e-commerce website, if you try to do giveaways from particular times that, oh, buy this, got this, or you are giving 50% discount, so or we are doing Black Friday or thereabouts, you notice that that time people will definitely rush your market. They wanted to come. A lot of people, this one will share to their friends, they share to their families, so that they'll be able to. Oh, this thing failed again. What's the issue? I'm coming now. Let me see. Let me just. Okay. So this thing failed again. Let's just try and see if that will fix it. Let's continue. So scalable. So you notice that there will be some time that your application will definitely wanted to increase in they will there will be increase in demand on the application that a lot of people wanted to access it and get what's it called on your application. Want to see your providers, yeah, what to provide, you want to access it. So that time that means you need to meet up with your customers' demand. definitely have to scale. So for cloud, they are scalable. That means you can meet up with the demand of your customer easily. Then it's reliable too. You come in, let me check the code that this one means. Okay, we have to upgrade this. Yeah, so let's see. The pip that we're using, it's probably not updated one, and that's what's causing issue. You go fix now. Yeah, so reliable, high uptime. So for when they see something is reliable, that means it's accessible every time. Like wherever you wanted to get it, you will be able to get. Not that it's going to be disappointing. That oh, you wanted to use this application now. For example, just think of your um application, yeah, like your banking application now. Majority of us know like some of the banking application used to be unreliable. Like if you wanted to use them, there will be some time that if they're experiencing customers this thing, they won't be able to meet up. So some people won't be able to do some transactions, right? Which majority of the fintech now are now really solving for us. So that reliable is there. That whenever you wanted to access your fund, it's there for you. Access it. Though there are some kind of techniques that they use to save funds too. So those times that they notice that oh you don't have people patronize this kind of product, they just bring it down or they just scale it down. Bring it down means they might actually stop it from working totally. Then scaling down is just scale it to instead of using big this thing like using multiple servers to run this thing using load balancing, you can just leave it to one particular node to handle it. You understand? And in cloud, you just pay for only what you use. Not that in the olden days that you have to go and buy a server. So now you don't have to go and get a server yourself. Just if you wanted to deploy application and everything, it's only probably within 2 days that you need it. That means it's only the time of that 2 days, 48 hours or less, that is you're going to pay for. If you need in the olden days, if you need something similar, that means you have to go and buy a server, you deploy application, then once you are done, probably be looking for another person to buy it or thereabout. So for now, cloud is just pay as you go. You only pay for what you use. So those are what we pay for cloud. And major cloud providers that we have, major of them, like the job, we have AWS, so it's the most popular and it's the most demand in the market, and also they actually take the larger share of the market in cloud providers. They have a lot of customers compared to others, right? And all of their services, it's EC2, and that's exactly like a virtual machine. Then they have ECS, that's the service that we told you're doing here. That's container service, elastic container service. Majority of AWS services that you see E in front of them, that means it's elastic. And when they say something is elastic, that means the thing is scalable. That's exactly what they are referring to. When they say something is elastic, definitely the thing can increase in size and it can also come back to the original size. That's what elastic means. And that's what the elastic is doing there. So when we have ECS, that means elastic container service. That means if you use this thing to run your container, you can scale and meet up with demand from users. You understand? And also, when there is reduction in demand, you can just try and come back and do also. And it's not good for everything, enterprise application, just everything I want to do. AWS is covered, like got it covered. So, so Google platform, they have their services. Virtual machine is the one that's similar to virtual and that's similar to ECS, EC2 rather, and they have compute engine. They also have different kind of service application, data analytics apps. They have it Microsoft Azure. So that one too. They have their container instances you can use. They have app service. So it's actually good for enterprise and some Windows application also. they are actually the one dominating anything that has to do with Windows. So now I want to try. So though in our next class we'll be deploying application, deploying this particular thing on ECS, right? We'll deploy it on AWS and see there was we'll upload our image to CR also. That's Elastic Container Registry. That's similar to Elastic and they're similar to Docker Hub. Yes. So yeah, there are a lot of services for which I tried out. I wanted to check them out. A lot of services in there. Yeah. So this thing is taking so much of our time. Yeah. I just hope it got built now. If there is question you can ask. If there is none, let's just wait for application to complete successfully.
Hello, 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 hello.
Yeah, hello.
Is there any problem?
No problem. We are waiting for the application to get built.
All right.
Yeah. Oh yeah, so our application it has finished building now. As you can see, it's done building. So what we have to do now is let's now try to run it and then map it to a particular what's it called? Particular port of our choice. Let's first check the Docker images. This one will list all the application that I have, all the Docker images that I have. That one, I think we have it to be named. What's the name? Yeah, Simple Flask app. So here is it, the last one. So it automatically tag latest. So this is the um you see the size of the application. That's 421 MB. So as you can see, some application can be more. See all this one, they are 2 point something gig. This 1 point something gig. So it's okay to be as it is. And you can actually still make sure we actually, if you follow some standard, you understand, you can still try and reduce it. So all the one that we've actually for, if we didn't do that, like trying to ignore some particular files, it will be more than this also. So now let's try and run the application. Use Docker, run them port. Okay. The port that we want this thing to be running on our local on our own host. If you understand. That's 8080. Then 5000 is the one that the application will be open to. Then the image, what's the name again? That's simple flask app. I just hope the name is correct. Oh. I mean the name of our application. I hope it's correct. Let's run it. If it's correct, we see, and if it's not, yes. So that means it's correct now. So this thing is telling us that it's running on 5 point like 5000. That one is for if you try to access it, you see. Oh, let's try and access it. Can you see connection failed? Code. There is nothing running on that 5000. It was because this one is showing us because this one is on this is the container fish. This one that we are seeing. So now let's try and change this thing to our own ports. 8080. This 8080 now. Let's try and can you see? So the moment you access this port on 8080, if you notice this one has received a new this thing, gets this thing from our client. So and it's done 200. That means it's working. So let's try and reload. You see, can you see? If you try to do some particular stuff, you see post. That means you put some particular stuff there. So now it's not working. So it's running on port 8080. So if you wanted to change it to another port also, yeah, you can also change it. So you understand? So this is just the development also. So you don't have to use debug mode in the production. But because you are using this on deployment, that's why we have debug mode to be. So it's also off also. Yeah, it's off. But we can actually make it on because it's just normal deployment, development stage. Yep. So that's the warning. That's what the warning is telling us. So is there any question so far? Let's try and change this port. If there's any question, ask after this. You are ending the class. So I will see the next. This host application. Let's try another port. Oh, oh no, 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 that's what I'm trying to do. I want to use another port. We used that one earlier. So if you try another port, let's choose 8000 instead of 8080. You see that it's still running on that 5000. So if you rerun this, nothing to show for it. This one is just here because it's cached and this thing is not is not working properly. Let me just connection failed. So let's go to 80,000. 80,000 rather. Can you see now? So application is on. That's how to change your ports on application now. If you want to change any ports, you know that the ports that you're mapping it to, that's exactly. And now let's check one last thing before we go. That one is rebuilding the application itself. You know, we've built the application before. You see how long it takes. Let's try and rebuild it again with the same name. See, and let's see. You see how much, how long does this take? That's 2.1 seconds. Because if you can check everything here, that's the only thing that reads more than 0 seconds. That's the power of catching. You understand? Now let's change the name also. That's, you see, the same thing. Because everything, you see this one even takes 0.4 seconds. You change the name. So changing the name doesn't mean Docker will not use that catch for your application. So far it's the same code. So you definitely use it. So now we can run this simple Flask code, simple Flask application. So that's basically it. Is there anyone with any question? If you don't have any question, then we meet in the next class. With education, please ask.